Good morning students. I hope you are preparing the notes topic wise because first time you are making the notes in such a way on the basis of the concept. Okay. So as we know that in our previous classes we have learned about some scalar and vector quantities, and as we know that to find these quantities we had some formulas so that we can apply this formula, and we got the value of this scalar and vector quantities. They are distance, displacement, speed, velocity and acceleration. Okay, so now we will move to our further explanation about these quantities with the different method. Okay, so learning outcomes of today's class are concepts of graphical representation of linear motion, distance time graph, displacement time graph and velocity time graph. So graphical representation of linear motion is when a moving body changes its position continuously with time. The simplest way to describe the motion of this moving body is by using a graph. So a graph is very useful in studying the linear motion of a body. It presents data in a compact or a short form. It also makes the comparison of the different sets of data in an easy way. Okay, so the linear motion of a body can be studied with the help of the following graphs, and these graphs are distance time graph to find the speed, displacement time graph to find the velocity, and velocity time graph to find the acceleration of a moving body. Okay, we will see these graphs in different conditions. As we have seen that the graphical representation of motion is categorized in three parts, that is the distance time graph to measure the speed, the displacement time graph to measure the velocity, and the velocity time graph to measure the acceleration. So our first graph is the distance time graph, and this is the geometrical relationship between the distance traveled by a body and the time taken. Okay, so the distance time graph of a body can be drawn by plotting the distance traveled by the body on the y-axis and the time taken on the x-axis. Okay, since we know that the ratio of the distance and time is speed, so the slope of the distance time graph gives the speed of the body. That means the speed of a body can be calculated from the distance time graph. So in this graph for a body, under the following three conditions are described below. So our first case is when the body is at rest. What will happen, or what that graph will shows when the body is at rest? When a body does not change its position related to a fixed reference point, it is said to be in the state of rest. Okay, so let us consider a body at a distance of 15 meters from a reference point. If the body is at rest, then it will remain at the same distance at all time. You can see in that table. Okay, therefore the distance time graph for a body at rest is a straight line parallel to the x-axis. X-axis, that means, or we can say the time axis. Okay, so the slope of any line parallel to x-axis is 0. So the slope of the distance time graph for a body at rest is 0. That means if there is no slope, that means the speed of this distance time graph will be 0 when the body is at rest. Our next case is the distance time graph for a body moving with the uniform speed. As we know that when a body covers equal distances in equal intervals of time, it is said to have a uniform speed. The distance time graph for a body which covers a distance of 10 meters in every second is shown in that table. Okay, so shown in that table, all the points that graph fall on a straight line. You can see in this graph, time is given on the x-axis and that distance is given on the y-axis. That means it is covering the equal distances of 10 meter in every second. Thus, the distance time graph for a body moving with a uniform speed is a straight line making an angle with the x-axis or the time axis. You can see here. Okay, now the question arises that how we can find the speed by this form, by this graph when the body is moving with the uniform speed. So, to find the speed when the body is moving with the uniform speed, we have to do some calculation, as we know that speed of the moving body is the slope of line OA. You can see here. Okay, so from here, as we know that speed is equal to distance upon time. So distance will be that AB. At any between the you can take any distance between 2 points like AB. So it will be D2 minus D1. Okay, and BC, that will be T2 minus T1. So in that way we can find the speed of that body when it is moving with the uniform speed, and it will be 10 meter per second. So when the body is moving with the uniform speed, it will be a straight line making an angle with the x-axis. Our next case is the distance time graph for a body moving with a non-uniform speed. A body moving with a non-uniform speed covers unequal distances in equal intervals of time. Therefore, the distance time graph for a body moving with a non-uniform speed is not the straight line, it will be a curve. Okay. The shape of the distance time graph for a body moving with a non-uniform speed depends upon the way how the speed is changing with the time. So in this case, two possibilities can be occur. First one is when the speed increases with time or when the speed decreases with time. Okay, so we will see about both the possibilities. Okay, so first one is when the speed increases with time. When the speed of a body increases with time, the distance covered by it per unit time also increases with time. Therefore, the distance time graph for a body moving with an increasing non-uniform speed is a curve whose slope increases with time. You can see the table, the time is equal or it is moving in the same way. That means when it was rest, the distance it was not covering any distance. Then after 1 second, it is taking the distance of 7 meter. After another 1 second, that means when after the 2 seconds, it covered the distance of 15. That means time is same, but the distance is different. But the it is taking that it is moving with an increasing speed. Okay, that means its speed is increasing. So in that way, the curve whose slope increases with time. So this is that that distance time graph of the body which is moving with the non-uniform speed, and when the speed increasing with the time. Okay, now we will see the second possibilities when the speed decreases with time. When the speed of a body decreases with time, the distance covered by it per unit time also decreases with time. Therefore, the distance time graph with the decreasing non-uniform speed will be a curve whose slope decreases with time. You can see in this table, time is going in that 1 second, 2 second, 3 second, 4 second, and the distance that is 20, 35, 45, 50. That means when we will find the value by the distance value of the speed by that distance, and by putting the formula of distance upon time, we got the value of the speed, and we will see that the speed is decreasing uniformly. Okay, so it will be a curve whose slope decreases with time. You can see in the graph how it is decreasing with the time. Now our next graph is the displacement time graph this is the geometrical relationship between the displacement and time. Here we will plot the displacement on the y-axis and time on the x-axis. As we know that the displacement of a body is a vector quantity and displacement has the magnitude as well as the direction. So the slope of the displacement time graph gives the velocity of the body. The displacement time graph for a body depends upon the nature of the motion of the body, then that means how it is moving. So here also we will see some conditions. So our first case is about the displacement time graph when the body is at rest. Okay. For a body at rest, the displacement time graph is a straight line parallel to the time axis. Okay, you can see in the graph, the slope of the displacement time graph is 0. So the velocity of the body will be also 0. In the same way which we have, which we did in the distance time graph. Okay, you can see in the graph, it is a straight line. Actually, the slope is 0. So the velocity in the displacement time graph will be also 0. Our next case is when the body is moving with the uniform velocity. Okay. So the displacement time graph for a body moving with the uniform, or we can say the constant velocity, is a straight line at some angle with the time axis, or we can say the x-axis. You can see the body is moving, that means with the uniform velocity. That means it is not changing its direction, it is moving in the particular direction. Okay. Okay, you can see, you know about that constant or the uniform velocity. So you can see in that second graph that body is moving with the uniform velocity. So it will be a straight line at some angle with the time axis. Now our third case is when the body is moving with the non-uniform velocity. The displacement time graph for a body moving with the non-uniform velocity is not a straight line but a curve, in the same way as we did in the distance time graph. As we know that if the body is moving with the non-uniform velocity, that means it is covering the unequal distance in equal interval of time in a particular direction, or it is taking that equal distance in equal intervals of time, but its direction is changed. Okay. So here also we see that two possibilities can be occur. That means it will not be a straight line but a curve. First possibility is when the body is moving with an increasing non-uniform velocity. Okay. So what will happen? The displacement time graph for a body moving with an increasing non-uniform velocity is curve. Here the slope of the curve increases with time because that it is moving with an increasing non-uniform velocity. That means its velocity is not uniform but it is increasing. Okay, you can see in the diagram or you can see in the graph, first graph. Okay. In our second possibility, when the body is moving with the decreasing non-uniform velocity, every time you must remember that when the body is body is moving with the decreasing non-uniform that speed or the velocity, the curve line will be that downwards. Okay. So when the body is moving with the decreasing non-uniform velocity, the displacement time graph for a body moving with a decreasing non-uniform velocity is a downward sloping curve. Here the slope of the curve decreases with time. That means velocity at point B is less than the velocity at point A. In the first case, that means here in the first graph, that means here velocity at B was greater than velocity at A. That's why the slope of the curve increases. Okay. But in the second graph, when the body is moving with the decreasing non-uniform velocity, here the velocity at point B is less than the velocity at point A. So, it is moving downward. Okay. After knowing about the distance time graph and the displacement time graph, our third graph is the velocity time graph, as it is mentioned in its name, that is velocity and time. So, the geometrical relationship between the velocity of a body and the time is called the velocity time graph. The velocity time graph for a body can be drawn by plotting the velocity of the body on the y-axis and the time on the x-axis. If we observe that in all the graph, time is taken on the x-axis. Okay, as we know that the ratio of the velocity and time is the acceleration. So, the slope of the velocity time graph gives the acceleration of the body. That means acceleration of the body at a point of time can be calculated from the velocity time graph. For a straight line motion, different types of velocity times graphs are possible depending upon the nature of the motion. So, we will see some cases is as we have seen in the other graphs also. So, our first case is when the body is moving with the uniform velocity. Here we are not taking the case when the body is at rest, because here we will find that acceleration by the velocity time graph, and acceleration is the change in velocity and velocity is the speed in a particular direction. So, we will talk about the moving body, not the bodies those who are in the rest. So, our first case is when the body is moving with the uniform velocity. Okay. So, the velocity time graph for a body moving with the uniform, or we can say the constant velocity, it will be a straight line parallel to the time axis. You can see in that first graph. Okay. Suppose the slope of the straight line is 0, that means there is no slope in that straight line, therefore the slope of the velocity time graph is also 0. The slope of the velocity time graphs gives the acceleration of the body. Therefore, the acceleration of a body moving with the constant on uniform velocity is 0, because acceleration is the change in velocity, but here body is moving with the constant or the uniform velocity. There is no change in the velocity. That means here acceleration will be 0. Okay, so in velocity time graph, when the body is moving with the uniform velocity, acceleration will be 0. Okay, in our next case, in the second case, when the body is moving with the uniform acceleration. Okay, when that body is moving with the uniform acceleration, when that initial velocity is 0, that means initially it was in the rest. The velocity time graph for a body moving with the uniform acceleration is a straight line making an angle with the time axis, or we can say the x-axis. It is the straight line sloping upward and passing through the horizon. The slope of the velocity time graph gives the acceleration of the body. Okay, you can see in the graph and you can see in this table also. That means time is moving 0 to 1 second. That means initial velocity was 0 and the time was 0. Then time is moving. Then the velocity in meter per second, that is 10 meter per second, 20 meter per second, 30 meter per second, 40 meter per second. Okay, that means it is moving uniformly. Okay, so now the question is that how we can find the acceleration. So we can find the acceleration, you can see in the second graph. Okay, to find the acceleration, we have to find the slope, that is OA. Okay, so as we know that acceleration is the change in velocity, or we know that the formula to find the acceleration is final velocity minus initial velocity upon time. So here final velocity will be 50 and the initial velocity will be 0. Okay, and time is 5 minus 0. So in that way we can find the acceleration by this graph, and it will be 10 meter per second square. Okay, so in that way we can find the acceleration by the different graphs. Our third case is when the body is moving with the uniform retardation. Retardation, that means here the acceleration will be negative, or we can say the body deaccelerating itself. Okay, so velocity time graph for a body whose velocity decreases uniformly with the time is a straight line sloping downwards. The slope of the straight line is negative because here body is moving with the uniform retardation. Retardation is means the negative acceleration. Okay, when the speed or the velocity is decreases. Okay, so the acceleration of the body is negative, or in other words the body is under the uniform retardation. You can see in this table the time is moving, that is 0, then 1, then 2 seconds, then 3 seconds, then 4 seconds, and velocity meter per second decreasing. Okay, that 50 meter per second, then 40 meter per second uniformly, because uniformly that means that rate of their decreasing, that is of 10 meter per second. Okay, so you can see in this graph also. So by this graph, how we can find the acceleration, or we can say if we are finding the acceleration in the case of that retardation, it should come with the negative sign. Okay, suppose if we are finding the acceleration in case third, so acceleration is that change in velocity. So the formula of the acceleration will be final velocity minus initial velocity upon time. So here final velocity is that 10, you can see in the table. Okay, and the initial velocity is 50 upon 4, that means in how much time. Okay, so 4 will be the time. So here we can get the value of that acceleration, and it will be minus 10 meter per second square. Minus 10 shows the retardation or the negative acceleration of the body. Clear? Now our next case is when the body is moving with the uniform acceleration and its final velocity is not 0. First we saw that when the body is moving in case second, when the body was moving with the uniform acceleration but its initial velocity was 0. But here what is the difference? That is the initial velocity is not 0. So the velocity time graph in this case is a straight line sloping upward in making an intercept on the y-axis. Okay, that means here it is not on the 0. That means initial velocity is not 0. It is moving with any velocity. Okay, so you can see in this second graph. So this is the graph which shows that when the body is moving with the uniform acceleration, when its initial velocity is not 0. Our fourth case is when the velocity time graph for a body, when its velocity increases non-uniformly with the time. That means velocity is not increasing in the same manner. Okay, so the velocity time graph in this case is a curve moving upward. If it is increasing, that means the curve will be the upward direction. Okay, the slope of the curve is positive and increases with time, and the acceleration of the body increases with time. That means the body is under the non-uniform acceleration. Clear? If it is increasing, that means it will be the acceleration, not the retardation, but non-uniform acceleration. You can see in the graph, first one. Okay, when the body, when the velocity increases non-uniformly. Okay, so the acceleration of the body increases with the time, that is the body is under the non-uniform acceleration. Okay, our next case is velocity time graph for a body when its velocity decreases non-uniformly with time. Here that velocity is decreasing, so automatically here some retardation is there. Clear? So the velocity time graph in this case is a curve moving downwards because the velocity is decreasing. So the direction of this curve will be downwards. Okay, so the slope of this curve is negative and increases with time. Clear? The negative slope of a velocity time graph indicates a time curve indicates the retardation of the body. Here the retardation increases with time, that is the body is under the non-uniform retardation. Retardation, that means the negative acceleration. You can see in this graph the body is moving with the non-uniform that retardation. Okay, now our next case is velocity time graph for a body when its velocity increases and decreases alternatively. That means in a single graph we will see the acceleration also and the retardation also. Okay, the velocity time graph in this case is a zigzag curve. Zigzag. Okay, that means alternatively it is accelerating or deaccelerating. So the body undergoes the uniform acceleration and the retardation alternatively. You can see here. Okay, the body is that accelerating and then deaccelerating, then accelerating, then deaccelerating, then accelerating. That means alternatively its velocity is changing. Sometimes it is increasing, sometimes it is decreasing. So it shows that a zigzag curve of the uniform acceleration and the retardation alternatively. Clear? So here this is all about the graphs of distance time graph and that displacement time graph and the velocity time graph. I hope you understood all the graphs. You just read this graphs twice or thrice so that you can understand even more better. Okay, and you can solve that solve examples also which is given at the last, the numerical which are based on the graphs, so that you can practice to find that acceleration or the velocity by the different graphs. Okay, so that's all for today's class. Thank you. Have a nice day.